And this video is going to look at calculating the x and y-intercepts for linear equations. I've included a graph with a line 2x plus 3y is equal to 6 that I created on Desmos. Okay. The x-intercept is what we're going to look at first, and that's the point where our graph crosses the x-axis. We know the x-axis runs horizontally. And we've talked about locating points in the Cartesian plane. The x-coordinate is always written first. So that point that my line is crossing the x-axis is at the point 3, 0 for this example. Okay? The x-coordinate at this point can also just be used to refer to the x-intercept. We could just say the x-intercept is 3, because the y-coordinate at any x-intercept is always going to be 0 because it has to cross the x-axis. Okay? For lines, we can either have, and in most cases, they have one x-intercept and one y-intercept. Okay, and this is true so long as the slope isn't equal to 0. If the slope is equal to 0, then the equation is just in the form y equals b, and it's a horizontal line. We could also have the situation where we have a line x equals a, and then there would be an x-intercept and no y-intercept, and that would be a vertical line. We're not really going to deal with those this semester. Now that we've talked a little bit about what an x-intercept is from a picture, let's look at how we find the x-intercepts for an equation algebraically. So because we know the y value has to be 0, we take our equation and we're going to work with 2x plus 3y is equal to 6. And what we're going to do is we're going to sub y equals 0 into our equation. So substituting that in and simplifying to solve for x, we end up getting 2x plus 3 times 0, that's 0, is equal to 6. So we get 2x is equal to 6 on the left-hand side. And then to solve for x, we need to divide both sides of the equation by 2, so x is equal to 3. Therefore, the x-intercept is at the point 3, 0. Going back to our original graph, we could also talk about the y-intercept. The y-intercept for this particular line is at the point 0, 2. We might be interested in finding that algebraically as well. So to find the y-intercept algebraically, if our equation isn't in standard form, isn't in y equals mx plus b form, but is in standard form, like in this example, then we take our equation, 2x plus 3y is equal to 6, and we sub in x equals 0, because at a y-intercept, we know the x value has to be equal to 0, and then we can find our corresponding y value. Substituting in x equals 0, that makes the 2x term go to 0, because 2 times 0 is 0. And so that means the whole left side of this equation becomes just 3y. Let 3y is equal to 6. To solve for y, we need to divide both sides by 3. And so y is equal to 2. Therefore, the y-intercept is at the point 0, 2. Notice that if we took the equation 2x plus 3y is equal to 6 and rearranged it so it was in mx plus b form, then we would have a slope of negative 2/3 x and then plus 2, and we could read the y-intercept that way as well. Okay, so the next thing to do is practice. You have 2 examples given. Try it out. Try and find the x-intercept by subbing in y equals 0 and solving for x. Find the y-intercept by subbing in x equals 0 and solving for the y value. Unpause your video and check your answers after you've done the work. For the first practice question, we find the x-intercept to be the point 60 and the y-intercept to be the point 0, -4. Be careful when you're solving to pay attention to the sign in front of the coefficient that belongs to the coefficient. We need to divide both sides by -3 to solve for the y-intercept in this example. If we go to a graphing software like Desmos that we mentioned before, again, we can easily enter in our equation and check the results. So 2x minus 3y is equal to 12. We can enter it in exactly like that. And we can identify the y-intercept and the x-intercept. Okay, going to the other example, finding the x-intercepts for the line x minus 2y is equal to 4. We find the x-intercept to be equal to 4. Okay, we don't have to divide by a coefficient because x has a coefficient of 1 in this example. When we substitute in, we can easily get that x-intercept value. And the y-intercept is at the point 0, -2. Again, if we want to check by graphing, we can enter the equation into Desmos. X minus 2y is equal to 4, and we can confirm our x and y intercepts. This means that you can try out as many practice questions as you want until you're fully comfortable with the techniques. Great work, and be sure to do your homework. Contact your instructor if you have any questions.